This is the 21st video in the video series of Orbital Mechanics with Python. This one I'm going to be going over NASA's Horizon system. But first I wanted to just mention that for now I'm done with OrbitPropagator. I spent a lot of videos on it because it's kind of like a really useful tool to have to be able to do more applications outside of it. But I also wanted to say that Orbital Perturbations, which I spent probably like 11 or 12 videos on, are just one subject in orbital mechanics where there's plenty more that I'm going to start covering now that I'm sort of done with OrbitPropagator. So I want to show you kind of this list that I have of a bunch of ideas. So JPL Horizon is what I'm going to do right now, and then the next I want to do this because I want to show you how to track the Tesla roadster trajectory. One of my subscribers mentioned that he wanted to see escape trajectory, so I'm gonna do that. And then after that, these aren't really in any particular order. So relativistic perturbations. So the orbit of Mercury doesn't follow Newtonian mechanics because of relativity. So I was gonna do a video on that. Optimal orbit transfers one, asteroid orbits, asteroid ejecta, parallelization of the computations. There's a lot of things that you can parallelize in order to just make them run a lot faster. Spice for orbital codes, I mentioned that I switched over, but it's not a very high priority to do that. Lambert's problem is a huge problem. Well, it's solved, but it's a huge thing in orbital mechanics. It has to do with orbit determination and other applications. Then later on I'm gonna add a spacecraft attitude to this, so I'm gonna go do a whole kind of sub-series on spacecraft attitude. LVLH, which if you don't know, that's local, vertical, local horizon frame propagation, so reference frames and all that, Euler angles, quaternions. Do some examples. I was thinking like a moon pointing attitude or a nadir pointing attitude, how to control it, and then be able to create a spacecraft class. So orbit where you have your entire state involves your position, your velocity, and also your attitude, and literally anything else in a spacecraft. Let's say battery, state of charge of your battery, solar cells, and everything. So I want to go over kind of how to put everything together. Yeah, trajectory and altitude or an attitude are all in one state. Solar cells and sun angles, how to calculate the sun angle with your solar cells. Checking for if you're in eclipse because there's no solar radiation pressure and you can't get any sun for your solar cells when you're in eclipse, obviously. Power generation, battery life as a state, as I said. How to be able to predict lunar eclipses based on ephemeris data on Earth. And then tracking near-Earth asteroids, so kind of using JPL also has a small body database where they have just their whole database of all the asteroids that we know of. So just going through that, and then going over, I thought of this the other day, just going over how asteroid redirect methods work, because that's one thing that's kind of, say an asteroid is going to come hit Earth, how can we diverge it? And there's multiple methods that have been proposed, and these are one of them. So gravity tractor, basically getting your spacecraft right up next to it for a super long time to get a little gravitational tug, and if it's far away enough, that's just enough to get it so it won't hit Earth. And then reflective painting as well has been proposed, where they talked about in the solar radiation pressure, that the coefficient of reflection, if you just cover the asteroid with a bunch of white reflective paint, for lack of a better word, there would be more solar radiation pressure, and it could make it go off course so it doesn't hit Earth. So those are just ideas that I have. I'm very open to any other ideas. If any of you have any, just let me know in the comments and I'll get to them, because I know this is all pretty interesting stuff and I like doing this kind of stuff. So onto NASA Horizons. I just wanted to mention that because, as I said, I spent a lot of videos on OrbitPropagator and now I'm done with it, so we can get to other cool stuff. So NASA Horizon Systems, what it is just a way to get ephemeris data, and it's reliable because NASA, JPL, we can trust them. They have planets, moons, comets, spacecraft as well. And I'm going to show you the online and the telnet interface. So I'll post a link to this, obviously. But basically, the Horizon system, online source system data and ephemeris computation service, and all that. So the horizons can be accessed following methods: telnet, email, and web interface. So first I'm going to show you the web interface. So go to that, where, say here you want to input, you want some ephemeris, and then you're going to input all the kind of values that you want. So ephemeris type. Instead of that, we'll do a vector table. So if you want to get, say, the precision and velocity of any body that we want, or if you want to get orbital elements as well, it's an option. So I'm just going to pick vector table. And for this example, I'm going to do the Tesla roadster because that's what I'm going to do in the next video. So target body, you can actually, if you go spacecraft, display the list, and then I just like to control F, Tesla, and there it is. So SpaceX roadster, select indicated body. And solar system barycenter is good for the coordinate origin. Time span, is actually needs to change because, oh shoot, I forgot when it launched. Let's see, or it's more Falcon heavy launch date. I have this in the telnet interface. It's a lot easier. So 6th of February. So we'll say like 7th of February. So in 19 February, say 7th, and then stop time is 19 February 8th. Oh, 8, step size 1 day. Yeah, we just need one, and then we're going to be able to propagate from there using OrbitPropagator. 1 day, table settings, defaults, yeah, and then generate Ephemeris. So then what you get from that is kind of this output page that they have, where you have a bunch of kind of information about what it is, background, dummy payload for SpaceX Falcon Heavy, and then when we get to, we have this epic, and where is XYZ? Here we go. So then this is the data you have. It gives you the date it is, in seconds since J2000, and then XYZ, VX, VY, VZ, and I forget what those other ones are. But basically, you get this data from them, and then from this you can plug it in, and then reference epic J2000. So from this reference you can, oh, and also needs to mention the plane of the Earth's orbit at the reference epic. Obliquity, yeah, explains to you kind of the reference frame, and it's the ecliptic, so that's more useful for the solar system. So basically you can get this data, and this is for any body. So say you actually wanted to do, I'll show you just all the options that you have for the target bodies: Sun and planets, Jovian, Saturnian, basically the Jupiter system, Saturn system, Uranian, Neptune, all this other stuff. So there's a lot you can do here, and there's a lot of data you can get from it. And then I wanted to show also they have a telnet interface, which I'm just going to get back to, let's see, Horizons. Telnet interface, that this goes through the command line. So there's a, if you prefer to do that, let's see here. Okay, so telnet interface, you go to the instructions. So what you want to do, I have this set up here. So you say, you just basically type this in, how to access a telnet interface. And any Linux terminal will have this. I don't think, or I haven't tried it for Windows, but I have the Linux subsystem on here, which is what I like to use. So the telnet, Horizon. So that's why I showed the online version as well, because if you have Windows, I'm not sure how to do it. I'm sure there's a way to do it, but I'm just not going to go over it. Horizons.jpl.nasa.gov 6775. So you do that, and then it takes you to this nice little interface where you can say type question for any questions, and it tells you kind of all about what's going on here. You can read that if you'd like. But basically what you can do here is to say I want to know where the Tesla is. So Tesla, it gives you a bunch of data about it. So I'm going to press Q, which Q ends display here. And then it says select, do you want Ephemeris, FTP, I'm not sure what it is, mail, redisplay, or help, which is the question mark. So I'm going to say E for Ephemeris. And then observe, how do you want to observe elements or vectors, or observe elements or vectors? Which observe is like observations, I'm pretty sure. So I want to do vectors, so say for the state vector. Coordinate center is at 0, that's the solar system barycenter. I just know that's something you have to look up, but I'm telling you. Reference plane, let's go ecliptic, so we go eclip. Starting TDB, so it tells you right here that it has to be after February 7th. So we'll just do, or after or equal to February 7th, so we're just going to do February 7th. Prior to, oh, never mind, I actually have to do February 8th. So, 2018, 0208. And then for the end date, I'm just going to do the next day because I just need one of these. 0209. And output interval, we'll just go 1 day, 1D. And then, so it has all these, and I want to have this in CSV format. So what you're going to do, accept default output here. I'm going to say no. And then output reference frame, we want J2000, that's totally fine. Correction, so it's going to go through all of these just because of the way that the thing is. And actually, I didn't want AU either, I want kilometers. So I'm going to go 1 for kilometers per second here. Spreadsheet CSV format, I'll just say yes. And then output delta T, TWT, yes. And select output table. So I like the one that they have here, table type equals 3, precision, velocity, LT range, so I'll just say 3. I'm not sure what the other ones stand for, you'd have to look it up, but, and then it gives you the exact same data that you saw in the online interface, so if you just keep going down. Oh, Okay, so it turns out I was actually getting some problems when I was doing CSV format. The data would kind of cut off. So you just keep the CSV format as no, and then when you get down here, you can get your X, Y, Z, VX, Y, VZ, and all that good stuff, which is exactly what you wanted. ICRF, J2000, ecliptic, and mean equinox. So you get all that. So that's basically how you use this interface, and you could do, say, any body you want, just like the online interface. So this one just happened to be this, where center body name is solar system barycenter, as I said, but you can be anything. It can be any asteroid, Earth, Jupiter, whatever you're looking at. So it's another different way of doing this, where sometimes they don't provide the SPICE files for, say, the Roadster, but you can still get the Ephemeris data like this. So that's just one way to do it. Yeah, just wanted to show that, just how to do that, because as I said in the next video, I'm actually just going to go ahead and do the tracking of the Tesla trajectory. So yeah, that's it for this video. Let me know if there's anything too slow, too fast, anything else you want to see. And and especially let me know for the list ideas, if there's anything else you want to see, just please let me know. And yeah, thank you for watching.